Sample problem 4.4 says how many grams of solute are in 1.75 liters of 0.46 molar sodium monohydrogen phosphate buffer solution. Okay, so there's a couple of things going on here, right? This is obviously a conversion problem. And I'm going to write down the thing that I know, right? I've got 1.75 liters of solution. And I know that I have my molarity is 0.460, and I'm going to use the units of moles per liter. And I'm going to tell you why. Anytime you're given a number in a problem that has two sets of units, that's a clue that that's going to be a conversion factor, right? That means I can convert from liters to moles or from moles to liters, right, using the molarity here. So I could turn this liters into moles by using that conversion factor if I used my T to do it, which is obviously what I'm going to have to do, right, because it's asking for how many grams. I have something that relates liters to moles, and then we also know of another conversion factor that will then get us from moles to grams, right? Remember molar mass? Molar mass has the units of grams per mole. So let's start writing down what we're talking about here. I'm going to start my T with my 1.75 liters. And the molarity tells me that in 1 liter, I have 0.460 moles. So let's see how many moles I have. 1.75 times 0.46. I have 0.805 moles of sodium monohydrogen phosphate. Now, how am I going to convert from moles to grams? I need the molar mass. But before I can figure out what the molar mass of sodium monohydrogen phosphate is, I need to know what the formula for that guy is, right? So remember, sodium is just going to be Na, and it has a +1 charge. You get that directly from the periodic table. Closest molar noble gas to sodium is neon. It loses an electron to get there. Now, the monohydrogen phosphate, that's going to be one of those polyatomic ions, and its formula is HPO4, and it has a 2- charge. So that means the formula then for sodium monohydrogen phosphate is going to be Na, and I got to have 2 of those, HPO4. Right? I got to have 2 sodiums to cancel out the -2 charge on the monohydrogen phosphate. All right, so now we can convert moles to grams by using the molar mass. So if I have 0.805 moles, let me write my formula here, HPO4, and set up my T. For every 1 mole of sodium monohydrogen phosphate, I've got to do my molar mass, don't I? So I've got 2 sodiums plus the molar mass of 1 hydrogen plus 1 phosphorus plus 4 oxygens. And let's see, I get 141.96 grams in 1 mole of that, directly from the periodic table, right? I added all of those atoms together to get that. Now my moles divided by moles are going to cancel out, and I'm going to be left with, let's see, what is our answer here? 0.805 times 141.96 equals, I got 114 grams of Na2HPO4. Right, so let's recap real quickly. I had to use 2 conversion factors here, right? I started out with a volume, and I could use my molarity to get me from volume to moles, right? They gave me the molarity. So that was my first conversion factor, the molarity. Once I had moles, I needed to convert from moles to grams. My second conversion factor then was the molar mass, because units of molar mass are in grams per mole, okay?